Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today I want to do a quick review of this Fosi audio BT20A. Is that right? Yeah, BT20A. I bought this some time ago and it just kind of got put back on a pile of things. And anyway, I was doing so many reviews, it just felt like that's all I was doing for a while. so I had to review some of the things that were given to me, some of the things I bought, which I have sitting around here. I just haven't got time to review, just so I wasn't doing reviews all the time. So anyway, we're going to do a quick review on this, okay? I'm going to run some tests on this. We're going to see what the power of this really puts out, and also the quality of that power, okay? I just did a bunch of tests on this Class A 20-watt amplifier. So if you haven't seen that video, I'll put the link below, because I'm going to run through the tests quicker in this video to make this a shorter video and a lot easier to edit. That took me it took me a couple, 2 or 3 days to put that together. So hope you gave me a thumbs up for that video. Give me a thumbs up for this video. I appreciate that. So yeah, the neat thing about this, I'll just give you a quick down low, is look how small it is. This thing, for being so small, my friend and I listened to this, the one that I built this amplifier for. He's got another Fosi that was actually sent to me by Fosi, which was really nice. So I got to get that back so I can review that one. But this one I bought, and this one's a bit smaller than the other one. The other one's bigger, larger unit. So this one, we both thought that it would be great for an office environment. It sounded good. But so in his listening room, it's larger than an office would be, probably. And unless, I guess there's some big offices. But anyway, a desktop, run some desktop speakers, things like that. This thing would be great. And it's small and compact. Another nice feature, I think, is the treble and bass. Some purists might think like, oh, you shouldn't be messing with those, but come on, especially if you have certain types of speakers that maybe don't have a lot of bass or maybe a lot of treble, you can kind of dial those in. Or if they're too bright, probably not going to have too much bass, but you can dial them in if you like. So yeah, it's kind of a neat feature. It's got a nice toggle power switch on it, and the knobs feel nice and everything. It's a nice metal box, nice construction, rubberized feet, make it soft, so not going to get vibrations through whatever you sit it on, probably. And the terminals, they're a little bit on the small side, especially for big old clubby hands. But I mean, for a small unit to fit all this stuff on the back, they kind of had to use a little bit smaller terminals. But you're probably not going to put gigantic speakers on this with big heavy wires, so it's probably appropriate. And then you have RCA inputs, okay? Yeah, the DC input 12 to 24 volts. So, and it says Bluetooth on it, so we'll see how the Bluetooth works as well, okay? Now, the one thing I want to say about this Fosi is, first of all, I like the packaging. It's not overly expensively done, so you're not feeling like you're spending a lot of money on packaging, but it is done nicely. And so, nice package, nice foam inside, protective foam. And let me see, the power supply that comes with it. It's just a brick. I was looking to see if it's vented, but it's not. So it's got an LED, I can tell right here. I have powered this up at my friend's house. We did listen to it for a little bit. Now the power cord, the DC power cord, does have one of those, looks like a snake that's eating something too large. It's got a ferrite bead, rubber encapsulated on the power cord, so that's a nice touch. Kind of keep down some of the high frequency noise from the switching power supply here. So that's nice. It is a Class D amp, so it's got its own switching noise, right? But all that stuff, well beyond your hearing, so you can't hear that anyway. But what we want to do is, here, I've got the manual right here, Fosi Audio. What we want to do is take a quick look. This says Bluetooth 5.0 2-channel, and there's a pin code. So, okay, and signal noise ratio is 98 dB, which is pretty amazing. It's equal or larger to that. Input sensitivity is 280 millivolts. So we'll see exactly what they mean by that. It says less than 280. So yeah, I'm not sure exactly. Does that mean 280 millivolts that it's at max power? Yeah, we'll see what they mean by that. THD is less than 0.5%, which I think is fine. So especially for a little small amp. Now here's where we can kind of tell the information is not correct. Output power is 100 plus 100 watts. Well, first, it doesn't declare what ohms that they mean that in. Now, maybe that is a max power or a peak power, or maybe that is something you could get out for transient periods of time. But you can't get that out continuously. That'd be 200 watts, right? And my calculations, this power supply is 24 volt, 4.5 amps. And that means 108 watts. So that power supply is only capable of 108 watts. So you can't get 200 watts out. You can't, I mean, let's say that it's super efficient, which I'm sure it is, and we could get 100 watts out. Okay, so I would believe that, but we'll test that. We'll see if that's true. And we'll see if it's true into 8 ohms or 4 ohms. We'll test it both. Now this says it goes down to 2 ohms, 2 ohms to 8 ohms. But I'll just test at 4 ohms probably. And you know, I think I'm going to test at 4 ohms. And if the power's not very good, then we'll go to 8 ohms. The Bluetooth transmission distance is 28 feet. That sounds reasonable. Frequency range is 20 hertz to 20 kilohertz plus minus 1 dB. We'll test that, okay? So we'll see if it's that flat. That'd be great if it was. So, all right, the rest of it's just talking about the input modes, Bluetooth or analog, or, you know. So, all right, yeah, so there's the little manual that comes with it. It's nicely put together. It's easy English, that kind of thing. There's quite a bit of information in that little pamphlet. So let's come over here to the bench and set this thing up and test it. I'll show you the test setup and we'll run through a bunch of tests. All right, let's do it. Hey guys, here is the QA401 audio analyzer. There's the power supply with the blue LED for the Fosi amplifier sitting right here. Okay, and I've been using this Unity for some test signals, but this guy has really low distortion, really low noise signal generator, so I'll use him for most of the tests, okay? And then up there in the corner right there, you can see it right over there. That's my Keithley THD meter. Then over here, you can see my laptop, which I'll be using the picoscope. Get my picoscope's hiding down there. So now here, right now, I got kind of a rat's nest because I got a whole bunch of stuff going on. I got the THD meter in here, but what I have is the left and right channel are shorted together with an input signal from the Quant Asylum and also right now from Unity. So yeah, it's just kind of messy right now. And then the output signal, I've got the scope from the picoscope here and the output from the Quant Asylum, and also I've got differential probes over here that I've got hooked up to the mix-sig. So yeah, I've got a lot of things. I'm just doing a bunch of setup stuff, and then I'll clean it up and we'll just have the Quant Asylum and the picoscope hooked up. And we're using 2 of the 4 ohm resistors hooked up, and we'll see if we have time to hook up the 8 ohms and see if we think we need to, okay? And then I got the power supply. Right now it's disconnected, but I've got it coming up the back side, so it's kind of away from all the other cords into the corner of this amplifier, all right? So there we go. And I've been using this guy just because it's easy to hold on to, but I really like my thermal cameras. I'm going to show you a new one, but when I'm just got a box, nothing really to look at, I'm just using this guy. And then back there, I've got my EEV blog, thank you Dave, and I'm using that to take some voltage readings and stuff like that. I love these probes, guys. I've done a review on these one time. I think I should do another one, but as my favorite probes. God, I want to say they're like $10, $15. Silicon leads, really nice handles, and long tips so I can reach in and poke things. And I've got a longer set. This is kind of the medium length. So there's a short length. Anyway, really nice probes. And then over here, I've got my Testo that I've been using for some measurements. So I've got its leads sitting right here. Also very nice leads that came with that meter. But, alright guys, that's the setup. Okay guys, this next test, what we're going to do is we're going to see how much signal we can put into this thing and not clip, okay? So we're going to look for the maximum power so that in the following test after this, you know, we can use that information. Let's just jump in this test and let's just look for the clipping level. You know what? And by the way, while we're doing this, I think we're going to see something else that's kind of interesting. So let's jump in this test. Alright guys, so I've got the picoscope running and I've got one measurement down here, the RMS measurement. Other than that, I've got plus minus 20 volts, so 20 volts up here, minus 20 volts here, so 4 volts per division. I've got my trigger set right here, so the 0 time set is right down here. And so if there's anything in the pre-trigger for the first, 1 second, okay, because this is 500 milliseconds per division, half a second, 1 second, we'll see that. And anything after, up to about 4 seconds, we'll see. What I want to do is, I found something interesting. I just want to show this to you. The amplifier's turned off, okay? There's no signal. Well, there's a signal at the input, but the volume's turned all the way down, okay? So I'm going to turn on the amplifier. Oh, and by the way, let me just show you this. Up here in the left corner, it says it's running. The trigger, we've got it on rising edge, and it is single mode trigger. So as soon as it sees something happen at this point, it'll trigger and it'll freeze, okay? It'll capture the rest of the waveform across the screen, but it won't trigger again. So let's do it. And look at that. There's a big spike here, and it goes up to about, I don't know what it goes up to actually, 24 volts I'm guessing, 24 volts supply, but just big old spike, and then it settles about 12 volts and then drops down. Let's see how high that spike goes. Okay, 50 volts. It clipped right there at 20, but look at, well, before we do this, let's pay attention to this. It takes about, let's say 3.5 seconds to get where the signal's pretty much 50% across the 0 line right here. But yeah, so man, that seems kind of crazy. For about 3.5, maybe even 4 seconds, we got a positive pulse. So that's probably going to put a thump on your speaker. Now, here, let me do that again, and this time we're going to see how high this pulse goes up. So we'll go 50 volts, so 50 volts up here. So let me reset it. When I reset the trigger, I hit this and the waveform just comes out to 0 and it's waiting. It's like, okay, it's at the starting blocks. Let's see what happens. So I'm going to turn it on. And yep, goes about 24 volts, about the peak of the power supply. So isn't that crazy? Now with the picoscope, I can also zoom into that waveform right there. And here, let's get a little more zoomed in. Take this hand, move this, whoops. I can do the undo button. What I really want to do is take this over to the center of the screen. So that way when I go plus, it just keeps on zooming in on that. Move it back over. I didn't have it quite centered. Have to really zoom in. And yeah, turns on, rings, and then, so that's what happens when it first turns on. That happens for the first, 100 milliseconds? So I thought you'd find that interesting. right? Okay, let's go ahead and zoom out. Okay, now what we're going to do is we're going to move this to the negative side. We're going to pull this down negative, okay? And then we're going to come up to trigger and say falling edge. And we're going to, I'm just taking a guess it's going to drop down, okay? So we're going to have to capture the negative edge. So let's go ahead and do that. Power supply is on, so it's running, okay? Or the amplifier's on, sorry. And there's no, the signal, the volume is still turned all the way down. Okay, now turn it off. Now there's not a spike because I guess it's on. So the voltage, I think when it's on, you get a plus minus 12. You don't have that 24 volt, availability at the output. But yeah, it drops down to probably close to 12. Let's see if I drop this down to 20. Yeah, so it's close to 12. So I find that pretty interesting. You're going to get kind of a negative thump, another thump on the thing for about the same time, about 4 seconds. Not as loud because it's this. Okay, now hold on a sec. What if we have, I'm going to turn it on. What if we do have some music playing? I'm going to turn up the volume a little bit, okay? Okay, there we go. I'm going to pull this down a little bit. So let's say we have some volume playing, okay? And then we turn it off. Does the same thing. Boy, that seems kind of crazy. Okay, now that we're off, I'm going to push this up here. I'm going to leave the volume on, okay? It'll trigger because of the volume. So, should I pull it up above a little bit higher maybe? I'll pull it up there. Let's try that. Okay, now it won't trigger. Otherwise, it would have triggered and we would have saw the volume go all the way across. Okay, so the volume's on. Hasn't triggered. Okay. And I turn it on. And look at that. I'm sure that went up to 24 again, but isn't that crazy? And, it comes down a little bit faster because we've got some music playing. So it does come down faster. So the thump isn't quite as long, but still, that's a little bit of a thump. It's a little bit longer than a second, right? A second and a half to get to this point, 2.5 seconds to get here. So with music, maybe it only takes a couple seconds, half the time, depending on the amplitude of your music. But boy, I just thought that was interesting. So this should be part of distortion specs, called the thump or something like that. Turn on, thump, something. All right, guys, so here's the signal. I got the amp on, it's running, and the trigger's not working very well, right? Just the show and tell on the picoscope here. We can go to, a lot of times you have filters that you set up, high frequency, low frequency, that kind of thing. This one has very interesting type of trigger, advanced edge, right, what they call it. And if you notice, this thing comes over here. I can pull it and drag it. Now it's on the falling edge. That's why it kind of looked different. Okay, so this is a hysteresis. Once it goes across here, this thing right here, see if I move that right on the crosshairs, it'll trigger right there. And then see this noise on this waveform? If it doesn't cross over past that and see the angle of this, I had to pull it down just past that angle. See what I mean? So if I'm up inside that noise, it's seeing that cross zero a bunch of times, right through here. It's just crossing zero a whole lot of times. I can pull this out and show you what it looks like. See what I'm talking about? This is a high frequency noise from the switching power supply, the Class D, it's a Class D. I call it switching power supply, but it's an amplifier, right? But it's Class D action switching, and that's what that frequency looks like. So as that keeps on crossing it's trying to trigger right there, but then it goes down and it comes up again, and so it's triggering it a whole bunch of times right here. So that's why it's having a hard time capturing that. So if I do this and zoom in on that like that, then that should capture it and freeze it. So that's how a digital trigger works. And so Pico has a digital trigger, which is quite awesome. All right, so what I'm showing you here is the waveform. And right down here, you see it's about 4 volts. And I'm just going to have to read this out to you. I'll set it right at 4 volts. Right there, we got about, 4 volts, 4 ohms. We have about 0.6, 0.7% distortion. If I drop this down to 2 volts, which is about 1 watt, okay, we're about 1% distortion. So I thought at 1 watt, that's where the distortion was set. Maybe it was in 8 ohms, so maybe that's true. But into 4 ohms, you get 1% distortion, and then as soon as you start bringing up the signal just a little bit, it goes to 0.5. So that 0.4, 0.3. So it does get better, and then it kind of starts climbing. Right there, it's about 1% again. Okay, that's about 4.5 volts. So 1%. Now I'm going to have to, this is plus minus 10 right now. I'm going to have to go to 20 so that we can increase this. See, the power supply is plus minus 12 because it's a 24 volt supply, right? And look at that. It flatlines just below that because you can see it starts to flatline a little bit higher, then I drag the power supply down by loading it, and then it pulls it down. So that's right there. We got 9.4% distortion. Pretty terrible. Okay, we're at 3% distortion. Still not great, right? And right about there, still 3%. And we're about 2% right there. So 6 volts, 2%. And we're about, 4.5 volts is about 1%. So that's the distortion specs I'm getting with 4 ohms. That's using the Keithley multimeter, the 2015 THD multimeter. So, all right, so now let's go look at this with the Quant Asylum. Now, one thing I'm going to tell you is this is with the Unity UTG962E signal coming in. The Quant Asylum is going to have a lot lower noise generator, so it should help clean up some of the noise at this lower power level. Okay, guys, now that we got the maximum voltage that we can, get out of this and be around 2% distortion, which probably is acceptable, I guess, Well, anyway, we're going to use that as our maximum, and we're going to start some lower value, do several different voltage levels, well, number 5 or 6 or something like that, and the last one will be at 6 volts, which V squared over R, 4 ohms, so 6 squared, 36, divided by 4, is going to be just over 8 watts, okay? So we're going to do this test, maximum at 8 watts. That's about all we can get out, and so, yeah, a little disappointing, but, I mean, that's a, 2% distortion. We go a little higher just before we clip, but anyway, so I just want to run these tests to start off at this level so we can get kind of decent numbers and so on, okay? The other thing we want to look for is they show a really good signal to noise ratio. That's where that 6, that first peak, whatever frequency it is, the next harmonic is going to be way down there. What is it, 90 something dB? So I want to check for that. So we're going to check for that too. We'll do that first, and then we'll run the Bode plots and plot the Bode. Okay, let's do it. Okay, guys, here we are running along, and this is the Quant Asylum audio analyzer. This is the 401, the QA401. I believe the 403 took the place of this 401. But right now what I'm doing is I have a 1 kilohertz tone and giving you a chance to read all this stuff up here. Signal and noise is 54 dB, not that 90 something. But then again, we're at that 2% distortion. So you know what? While it's running, let's go ahead and drop this down and see how good of a signal noise ratio we can get. See it right here? I'm almost at that 2 volts, which is Yeah, I don't know about this signal noise. It seems to get worse as I drop it down. So you can see the signal here. Here's the first harmonic, and it's, let's see, if we got -10 here, this is about -35, so yeah, it's like 20, yeah, right there, so that's about right. So I don't know about that 94 dB thing. Now let's see here, if I just max this out. Now see, remember what happened. Look at all those harmonics that are happening when I'm maxing it out. Yeah, not very happy. Not only that, see this spike over here? This is interesting. The power supply is starting to get a workout. This is the 120 hertz from the power supply, I believe. Look at that. So even the power supply is starting to have a problem. So we probably need a better power supply for this amplifier. But let's drop this down to 6. And this signal noise ratio also gets about the best when the distortion's the highest, or the THC's the best. Okay, right around 6 volts is 2%. You know, we go down 4.5 volts, we get that 1%. Let's go down 4.5 just to see. Yeah, signal noise ratio, that's 4.5, 52. So it doesn't change a lot from there to, say, just over 6. Actually, it gets a little bit better. So that's just before the THC starts getting real high. So right here, THC of -42 dB and 0.7%. So interesting. Here's THC plus N, not much higher because we're doing pretty good. It's a bunch of harmonics. This noise in between the harmonics we don't really see. That's why these two figures are about the same. All right, so that's interesting, right? Okay, the noise floor on this thing is about -70. I got this at 3 hertz just so it operates faster. I could get a little bit better, but it just starts slowing down a lot. But maybe I'll go right there because, yeah, it's a little bit smoother. And now we're about 1.5 hertz. I could get better, but man, it just gets really slow. Let me show you. It's got a lot of data to collect. We're less than a hertz, 732 millihertz resolution. So it's every, 1 hertz, it's taking a data point, or every, less than 1 hertz, right? So let's go ahead and speed this up. Otherwise, this test, for this next test especially, it doesn't really matter. Yeah, see, we can go, 180, we can go really good with this noise floor here, but we don't really need that kind of let's see. That seems like it's moving pretty quick. For a Borbede plot, which is the test we're going to do now, we don't really need to have really low distortion for a Borbede plot. So let's go ahead, and as far as resolution, 1.4 hertz, I think we can agree that's going to be good. Now, my screen is showing 10 hertz to 30 kilohertz. So let's go ahead and run this test. Maybe I need to stop this one. Okay, come up here. We're going to do this amplitude frequency response. Okay, let's run this test. 10, from -10 to 0. 0 dB will give us this voltage right here, 6.2. That's where we are right now, 0 dB input, which is, I'm not sure what voltage that is. I'd have to calculate the gain and go in reverse or measure the input voltage. But right now, we're at -10. You know what? Maybe I'll measure it as we're reading this, and I'll call it out. Okay, let's go ahead and start it. We're going to capture the plot of the phase and the gain. Let's do that. And I'm going to move this away from our measurements so you can see those things up there. And you can see this figure going across, and it's taking the gain and phase at each one of these steps. And like I said, it would go a little faster if I would have had a little less resolution. That's 240 or 270 millivolts in. Kind of jumping around as it changes frequency, so it's hard for me to tell. And the volume knob's set like somewhere in the middle probably. Okay, I think that's 380 millivolts. It says minus 8 dB at the top of the screen right here. This looks like about 480 millivolts input. You can see up at the top it's minus 6 dB correlation. It's about 580 millivolts, I think, 590 millivolts. And it's minus 4 dB at the top. And you can see the tip of that peak kind of drop down right after 20 kilohertz. There's 20 kilohertz right there. Now watch it drop down. That's probably about, I'm not sure, 700 millivolts. Again, it's hard for me to tell because it's reading, turning off, reading, turning off. And minus 2 dB at the top gives us 3.7 volts RMS output, roughly. So that's roughly 4 watts. One thing to point out, over here on the left side of the screen, you don't see 60 hertz and 120 hertz spikes from low frequency switching power supply. This is a high frequency switching power supply, so yeah, pretty quiet on the low frequency side where our hearing is, where we can hear that. And this is our 0 dB where we got right around 6 volts RMS. It's a little bit less than that. All right, and there is our graph. I'll stretch this out. And there we go. I'm going to turn the phase on first. So I got to come over here my markers. My max marker is 180, I think. And I'm going to do the minimum of minus 180. See on top we have the phase on the right side and gain on the left side. These are all the phases. So they're starting off around 90 degrees, I'd say, right around here, dropping down to, down in whatever the degrees are here. And then they kind of go haywire because I think it's the way the timing, the filtering of the capturing and the Class D running, I believe, is what causes this problem over here. Over here on this gain, let's come up here and say Y1, and let's go to 20 dB. Let's see if that captures it. Man, all these gains must be right. See these things right here? This looks kind of interesting to me. I'm going to go a little bit higher, okay? I'm going to go 40 dB just to see if there's anything up there. Nope, there's nothing up there. So we'll back up and go 20 dB, and we'll make the minimum, we'll make it, what should we make it? Minus 40, stretch that out a little bit. Okay, now it's stretched out a little bit. Wow, so these are kind of crazy curves. Yeah, these curves are really interesting to me because if this is the gain, this black one up here is the gain at minus 10 dB at the real low signal input. It's like, man, the gain is like really low, and at 20 hertz crosses 0, its gain is 0, and then the gain increases as we go up. Wow. and then they're all on top of each other. I mean, they're on top of each other the whole way, it looks like. These curves are really interesting to me, that they're so perfect. I mean, so perfect as far as every level is looking exactly the same. You can barely see the different colors in this one in the phase, but in the gain it comes up, and right around, what is this, 1K 908.76, around 500 hertz on, it's flat to about 10K, and then it drops a little bit at 20K, and then drops like a rock. Alright guys, boy, that is not what I would expect. I'm just kind of baffled. I would have thought it would have been flat across here. So, yeah, not very good at the low frequencies. Oh, you know what? Oh, geez, guys. It does have this, shoot, I forgot. It has the controls for the, yeah, it has the bass and tweeter controls. Holy cow, they actually work, because, you know, there's no indent on them, but I actually have the bass turned down, so it's actually doing just what it should. Wow. Okay. Sorry. Well, it shows the bass works, right? So let's go ahead and I'm going to have to adjust this bass. I'm going to have to adjust these knobs manually, okay? Like I'll have to do down here, say at 30 hertz or something like that, and get the same level as I do at 1K. And then that's probably also why it's starting to droop off here, because that knob, the treble one, it looks like I got it set towards the middle, but it's probably off middle a little bit. So right around here, it's actually dialing it down. So those bass and treble knobs do a good job. Wow. Okay. We need another test. Smells like burnt semiconductors. Alright guys, so what happened was I turned this amplifier back on, I put the bass in the middle, I put 100 hertz on the generator, and I did not see a signal. And I played around a little bit, and then I reached over and felt this, and it was really hot. Now the chip, I would have thought, would have protected itself thermally, but maybe it's not the chip. But man, this thing is still really hot. It's down around 47 degrees right now, but it was around 50 degrees when I finally measured it. But yeah, just feeling it, it's pretty warm. So, and the box is sealed pretty good, but I can smell semiconductor. So, or it could be a burnt resistor, I don't know. But something's not happy. Wow. Now the amplifier still shows or the power supply still shows a blinking blue light. So, you know what? First things first. Troubleshooting. I'll disconnect this guy. I've turned it off. It's been off for a bit, and I thought it'd cool down real fast, but it must have failed and was getting real hot at the time I turned it on. And who knows? Maybe even the power supply is still heating it up. Maybe something burned up. That's not, you know that switch. I think it feels like a mechanical switch, so I would think that it would mechanically open but maybe not. You never know these days. Alright. My EEV blog meter got tired of waiting for me, and it's in AC mode. So you know what? I got 24.5 volts on this, so that looks good. So the power supply, now it's a solid blue light. So that blinking blue light must have been saying, I'm not happy. Which is interesting, because again, it's kind of making me feel like this switch is not a hard mechanical switch, which is too bad. Especially since we're only coming in with a DC supply. Now, a lot of times they'll use an electronic switch. You know, it goes in a hibernation mode when you turn it off. It's always really nice to know whether it's actually a mechanical switch opening power, or in this case, it seems like it's just telling it to go to sleep. They do that because it's a small value of current going through the switch, and they can use a lower cost switch, and they can, you know, they can just go to a chip and say go to sleep. Another reason why I thought it was a mechanical switch is that testing that we did when we powered it on and off. That's usually what you see with a mechanical switch. So, interesting. Next video, we're going to open this bad boy up and do some troubleshooting, guys. So, unfortunately, I thought I was going to do a quick, you know, comparison to the 20 watt Class A amp output to this one. But I kind of got some Borbede plots, kind of got some distortion meters, kind of got some power levels. I mean, we can see it's not putting out the power that you would think you'd get by reading this. But the quick test is always to look at the power supply that's feeding the amplifier to see what its max power is. And if it's a 2-channel amp, you got to divide that in 2, right? So, alright guys, let me know what you think of the video. I tried to do a quick test. The troubleshooting video will be a video on its own, okay? Coming to the station near you. It goes like that. I'm in the lab, I'm working, and a lot of times there's problems. And, you know, in the past I've just corrected them, but I think you guys like troubleshooting videos, so I'm going to start showing those to you. Let me know in the comments if I'm right about that, because, you know, I'd probably just have corrected the problem in this if I can and just moved on. Or there's been times when it's not worth it to me and I just do another video and I've just wasted a bunch of time. But if you like these repair videos, which I showed you recently one, I've done a couple repair videos, let me know and I'll put those on camera. So alright guys, hey, by the way, that Hewlett-Packard, that dual tracking power supply up there, I think I'm going to sell all those power supplies over there, but that one side's not working quite right, so that's another repair video. And then I think I'm going to get rid of all those power supplies. It's just taking a lot of room, and I wanted a bunch of linear power supplies, but I don't want them anymore. Alright, you notice for audio reasons, right? I mean, I thought the linear, now those are linear power supplies because they're linearly regulated, so they are linear power supplies. On the front end, it's a low frequency switcher, rectifiers, diodes, commutating on and off, switching on and off. So you got that low frequency switching at 60, 120 hertz in the US. But then it goes through a capacitor bank and then it's linearly regulated. So those are linear power supplies. In most audio gear, they're not linear. There might be some low current linear regulators inside the power supply, but the power supply rails are often fed with just low frequency switching power supplies, which are in your audible hearing range. So when you see me do these spectrum, like when I did the one on this 20 watt, you could see the 60 and 120 hertz spikes sitting there all the time as my signal went across to create the Borbede plot. I like watching this Quant Asylum build a Borbede plot because it's kind of neat to see the spectrum on each you know, on each signal level as it travels, you know, sweeps across the screen. And what do you guys think? Do you like that? I like that. And you can see how clean the low frequency end was, which is audible, right? We can hear that. You can see how low that distortion is. It's non-existent with the switching power supply. So yeah, with this guy feeding this, it was non-existent, which makes me want to build a switching power supply with a Class A amp with the switching power supply front end. take out some of that noise. So, alright guys, thanks for watching, and 2 thumbs up to my patrons as always. Appreciate you guys. Appreciate you guys hitting the super thank you button down below. Buy me a cup of coffee. Appreciate that. And you know what? You can help the channel for free by just giving the thumbs up, giving me a comment. Let me know what you think. This video is kind of a failure video in a way, right? But it's going to lead into a repair video. It'd be a long video if I did both, and I'm just chatting away. So thanks for watching. We'll see you next time.